Hey, what's up? This is a special video for room 10 because it's a little science breakdown video. Oh, hey, there's our friend Lou Ferrigno there. We'll come back to him in a second. Hope he doesn't keep popping up. Scares me sometimes. All right, so quick rundown of what you guys have covered so far this week, week one of your in-home learning. So you guys learned about what matter was. Basically, it's anything that has volume and mass. And then once again, volume is the amount of space that a substance takes up. So all of these things around us take up space. So they're all made out of matter. I always like to say some joke like, what's the matter with you? Because we're all made out of matter. Sweet. So, volume of a solid on page 57. If you look in your science books real quick, if you need to, pause the video, you get there, you open up to page 57, and then once you're on 57, go ahead and hit go. And we're just going to run through and get caught up to where we're going to be when we start on Monday the 30th. So let's check this out. So on page 57, we talk about the volume of a solid. And, you know, we've done a little bit with area and math, but now we're going to talk about volume. So volume is length times width times the height. So all three of those calculations go together to give us a volume of a shape. Now, notice at the bottom of that page, there's like a little fish bowl with water in it, and then there's a bunch of marbles or rocks in the other one. That's another method for finding the volume of items that are oddly shaped. So if you had some car keys or like the marbles there, and you wanted to see how much volume there was, you could measure the water. So, okay, we've got 1,000 milliliters of water, and you drop those marbles in, and it pushes up to 1,250 milliliters. The difference from 1,250 to 1,000 shows us that those marbles were equal to 250 milliliters, or also 250 cc's, because 1 millimeter equals a cc, a cubic centimeter. All right, turn the page with me. Now we're looking at page 58. Now, mass and weight. That's why I had a picture up here of Lou Ferrigno. He was a famous bodybuilder. He was like the original Incredible Hulk back in the 70s because he's ginormous. But mass and weight. So mass is the amount of material in a substance, and weight is the measure of the amount of the force of gravity on something. So mass is what you're made up of, or what something is made up of. When you go to the doctors, they measure your height, they measure your weight, and they'll come up with a number called your BMI. It's your body mass index, and it tells you how much of your body is made up of fat. Yeah, just the way it works. Sorry, kids. You know, as you get older, it gets worse. Trust me. No, just kidding. You know, you go and then they run the numbers, and there's calculations for that, and it gives you a breakdown of how much of your body is made up of fat. Now, there's other tests they can do to find out how much your body is made up of muscle, which is also pretty awesome, in the organs, in your bone density, and all that kind of cool stuff. So, to look at mass, though, to show you how mass and weight can be different, I'm going to jump back to my buddy Lou here, good old Louie. There he is. All right, so this guy right here, right there, this dude right here is almost the same height as me. He's like an inch shorter than I am. But at this point, we weighed the same. So like he's like 275 pounds. I'm right in that range too, like maybe a little heavier, you know what I'm saying? You know, but we're like the same weight, but obvious, like by looking at the picture, our mass is different. Our body makeup, what is inside of our bodies, is different. He has more muscle mass than I have, although it'd be pretty sweet to be jacked like that dude right there. But, you know, it is what it is. All right, cool. So that shows the difference between mass and weight. We weigh the same, but our mass is different. Cool. Let's go ahead and look at the density page. Go ahead and shut that off. Cool, so on the density page on page 59, check that out. There's a really cool thing. Density is the amount of matter in a certain space. So looking at some of the density of the objects is pretty cool. Like gold is super heavy, that's why it sinks. Like when they pan for gold, the gold falls to the bottom because it's super heavy. Notice water. Water is 1 gram per milliliter. And then notice ice cube is 0.92 grams. That's why ice floats. It is less dense than water, so that's why it sits at the top. Wood is 0.7 grams per milliliter. That's why they made boats out of wood, because it would float. That was pine, and oak is even less dense, so it's 0.4 grams per milliliter. So that oak would float almost twice as good as the pine would. And then there's cork, which is kind of like a spongy wood type material, and that's 0.2 grams per milliliter. So that's like super, not very dense at all. So it floats really, really well. Let's see. So kind of cool on that page, the creation corner, check that out. It says most substances have a greater density in a solid form than in its liquid form. One exception is water. So normally if something is solid, it's heavier or more dense. So you take an item that was a liquid, you turn it into a solid, and it's more dense. Water is the opposite. You turn it into a solid, it's less dense, and that way it floats on the top. So it's pretty cool that God made water that way, because during the winter, ice floats on top of lakes and rivers instead of sinking. If the ice sank, it would continue to push the water out of the lake as it continued to go deeper and deeper, which would cause it, to kill all of the fish and whatever else are living underneath the ice. Basically, they'd be crushed down to the bottom of the lake. But luckily, God thought that through when he created all this stuff. God designed ice to be less dense than water, and in this way, he provided a top layer that keeps the water below from freezing. So, especially at the big lake, you have a foot or two of ice on the top, but you have tens, if not hundreds of feet underneath that ice that aren't even frozen. And, the fish and everything can swim around in there having a happy little life. All right, let's turn real quick to page 60. Turn a couple pages. Sweet, on page 60, we got a little thing about the physical properties. Now, the physical properties are the properties you can see, you can touch, you can feel them, you can smell them, you can taste them. Awesome. So, you can look at a rose, you can tell it's a rose. You can smell it's a rose, you can feel how soft it is, you can touch the thorns and know it's a rose. All those things are physical properties that God's given us to know what things are around us. States of matter, check it out. There's 3 main states of matter that we talk about a lot. So this is a little bit on 60 and 61. So those 3 states of matter, we got what? Who thinks they know what? I think Mrs. Gutierrez shared with us when she came from Riverside Public Utilities about one of these, right? One of them was a solid. The one she shared a lot about with us was what? Who remembers? Let's see. Who could I call on over there? Ryan, what do you think, bro? What was another thing? So we got a solid. What else was she talking about? That's right, liquids with the rain, right? So we got liquids, and then remember she was doing this stuff, and it was like the hands going up in the sky. Remember, what was that talking about? Gases. So we got solids, liquids, and gases. Awesome. So if something is a solid, it has a definite shape, and it has a definite volume. Definite shape, definite volume. Now, looking at liquids, if we have a liquid, it has a definite volume, so I know it's 100 milliliters, it's definite, but it does not have a definite shape. With a liquid, it takes the place of whatever container it's in. So, the liquid in this cup right here, if I pour this out right now, it is not going to stay in the shape of the cup. It is going to go all over the desk, right? So, we wouldn't want to do that. So, solid, definite shape, definite volume. Liquid, definite volume, but no definite shape. It goes wherever. Uh, cool. And then with our gases, you can turn the page to page 62 in your book right now. Turn to page 62 in that science book, and a gas. Now, a gas does not have either of them. It does not have a definite shape. It does not have a definite volume. You release it from the container that is holding it, and it goes everywhere. It takes off. The molecules in a gas, there's no attraction keeping them together. So in a solid, those molecules are stuck together. They're kind of vibrating, but they're together. Now with a liquid, they're still connected a little bit, but not a lot. With a gas, those things are all over the place. They are not connected at all. Let's see. Let's look at page 63. So look at page 63. We're going to talk about physical changes. That's where something is physically changing from a solid to liquid or to a gas. So if I take an ice cube and I set it on the counter, it's going to melt, right? So melting is taking a solid and turning it into a liquid. Now, we always think of melting being, something that's really hot. Like, it doesn't have to be really hot. It just needs to be a little bit past where its solid point is, like where its freezing point is. Turn to page 64. Now, freezing is anything going from a liquid to a solid. And normally with freezing, we think like, it's got to be freezing cold. No, that's not necessarily the case. Because if you have liquid metal that you have, at 2,000 degrees, and you go ahead and turn off the heat, it will slowly start to turn back into a solid. Because freezing is turning back from a liquid into a solid. Now, it might still be 1,500 degrees, like burn your fingers off kind of stuff. Like 1,500 degrees, but it's freezing. Try to wrap your brain around that for a second. Because you're like, what? Wait, it's hot. How could it be freezing? Because the term freezing is just a liquid turning to a solid. It's not getting cold and becoming a solid. It's just that liquid changing to a solid. So that freezing point could be really, really hot, depending on the material that is freezing. Cool. Vaporization. I'm going to start with evaporation. So evaporation, it's been raining lately. There's puddles on the ground. You go outside, you jump in the puddle, you come back out a few hours later, puddle's gone. So what happened was that water evaporated. So it turned from a liquid into a gas form. And now it's floating around. It's humidity. It's in the sky. It's in the air around us. And evaporation happens just at natural temperatures. Now we're going to talk about vaporization. Vaporization is when you have that water boiling, like you put it to 212 on the stove, you sit it on there, and it's bubbling. Every time one of those bubbles pops, it's releasing that liquid as a gas into the air. So sometimes if you boil lots of water, like the underside of the microwave will be wet. Like if you feel up there where the fan is above your stove, it can get wet from that. But vaporization is that liquid's boiling point. So like the boiling point of some metals, like 3,000, 4,000 degrees before the metal will actually boil and turn into a gas form. So that's kind of cool. And then condensation. Condensation, my friends, is when it gets so cold on the outside of the cup and the air touching it actually turns to liquid and it sticks to your cup. And then it runs down the cup and it makes a big mess on your table. If it's your wood table at home, mom's like, hey, you just messed up the table. Like she's getting all, upset and making you wash the table down, clean it down. So condensation is that the gas turning into a liquid once it gets cold enough. Once the air gets cold enough, it'll turn to a liquid. You go outside in the morning, if it's been really chilly outside, depending on the condensation or the certain temperature that becomes, the air will turn into liquid. Like stuff will be wet. You walk on the grass with your socks, you're like, oh man, my socks are all wet. Yeah, happens all the time, trust me. Cool, and let's see, I think that brings us to the end of week 1. And then my next video, I will pick up with you guys, and it will be for March 30th, that Monday. And we'll be going over pages 66 and 67. So you should be writing down your vocab words. Remember, those are the bold black words. Write down the definitions for the pages that we've covered. And we should be doing those quick checks every few pages. Remember 3 or 4 questions down the bottom right-hand corner. Rock and roll. I will see you, room 10, pretty soon.